Hey guys and gals, welcome back to another edition of Tekken 10. My name is Steve, and you guys might know me as Sin0822. Maybe you know me as Steve B. Maybe you knows me as just Steven Basiri. But I have this YouTube channel under Sin0822, sinhardware.com, all that good stuff. Want to let you know something right now that I'm just saying this because it's one of my first videos after a long hiatus. But I am now the CPU, motherboard, chipset, and overclocking editor at Tweaktown. I'm the only guy there who deals with those things, and we are a pretty large site, and I've put a lot of pride in my reviews. Now that I have access to motherboards that are different from the rest that I've previously reviewed, I will be doing reviews on MSI, ASRock, EVGA, BioStar, Asus, Gigabyte, all the major brands, even ECS if they send a board. BioStar sent a board too, and I'll be doing video stuff on those too. So if you want to see like the intricacies over video rather than reading my reviews on www.tweaktown.com, then you can definitely come to my channel, and hopefully I'll have some nice reviews for you there. So today I'm looking at Z97 Gaming 9 ACK from MSI. Why did I start off with this board? Because I love the audio section on this board. I am a sucker for good circuits, and this board has some good circuits. So this board has been out for a while, I'm not gonna lie. I reviewed it kind of past its prime, like it was already launched, but if you're still in the market for a really killer Z97 board for gaming with some of the best audio, if not the best audio I've seen on Z97, keep going with this review because you're gonna like what you see. Anyway, so we got the Gaming 9 ACK. I'll say that maybe 5-10 more times before the end of this review. You see this red thing here? That's what gives the K to the ACK. This is a killer 1525 wireless AC controller, and it does something with the killer E2205 right here called Killer Doubleshot Duo, or Pro Duo, or something like that. And it has a really cool way of allocating bandwidth that I haven't seen before, and that is kind of unique to Killer, and that can only be done with Killer NICs. Basically, it allows for both of the controllers to work together. So wireless AC can never really be as fast as the wired NIC. That's true. A 2x2 wireless AC maximum is 866 megabits per second. That's if the link negotiated is 866 megabits per second. The issue with wireless AC is that distances play a large part in performance. And the truth of the matter is that wireless AC can't reach as far as wireless N can, especially not in a house with thick walls. But it still has a little merit. So if you're in a room with wired and wireless, you don't have to just give up the idea of wireless altogether. What Killer Doubleshot allows you to do is basically program it so that all the gaming stuff will go through your fastest NIC, your wired NIC. Everything, such as Windows updates and that, used to be throttled when you use Killer through the software. No more do you have to throttle that anymore. All that can just be shifted into the wireless NIC. So the wireless NIC will handle all your other traffic. You can even be downloading a game and have no effect on your wired performance because it'll all be on wireless. That's something unique to Doubleshot and Killer, but you have to have at least two Killer, a wired and a wireless. And Killer will automatically find which one is slower, but I think it's already programmed just to know wireless is slower. And it'll just offset all the bandwidth on there. And you'll be seeing this technology a lot more, but I think this is the first time I've ever seen it was in this MSI board. So, yeah, props to MSI. Anyways, let's start off, right? So this is the board, beautiful red and black. And MSI, I love their dragon. So sexy, right? It's just cool, you know? I'm 26 years old and I find that pretty cool. I don't find it tacky, I don't find it boring, I don't find it kiddie. I find it pretty cool. Anyways, I've already unscrewed everything, so moving the board around is going to look kind of awkward to you guys. Let me just remove the heatsinks while we're at it, right? So, heatsink is wired to the board. Why is it wired? Because it lights up. Okay, so let me bring this closer and change the zoomy. Okay, so first of all, excellent MOSFET contact to the low RDS on power packs. There's 3 pins here, so it's not RGB. RGB requires at least 4. But I think it has to do with something with pulsing or something like that, because it does pulse if needed. So this is clear plastic in here, and it lights up, and the lighting on this is really spectacular. It looks really good. Everything is solid, and there's these little dragons hidden. You would never see these otherwise unless you took it off or looked at the board from a weird angle. But I mean, it's just the attention to detail and the aesthetics is really quite nice. Moving along, let's take a look at the PCH. PCH heatsink, same thing, really nice brushed aluminum, and we got our gaming series dude. Contact is good, but really PCH doesn't get very hot. I doubt it even really needs a heatsink larger than like just this. But every manufacturer, you know, has to put in their own like pizzazz or whatever you want to call it. Okay, this is the shield. It has no purpose. Maybe it helps EMI, but I really doubt it. It does cover up the beauty stuff. I don't know why you do that, but I guess people like not looking at circuits these days. But, I mean, you're my viewer, right? You must love the circuitry. Or, when I was small, I always used to look at it and look like, hey, this is a city. It's really cool. Well, if this was my city, then it would be a pretty fun city, because the audio on here is rocking out. It'd be like huge concert city, because the audio is sick on this board. We'll cover that. I didn't remove this shield. This just covers the I/O. I might as well cover the I/O panel while we're at it, right? Oh, look, part of the heatsink came off. Oh, the heatsinks are screwed in by metal through the back. Metal is what you want for that. Okay, this is the I/O panel, right? We have PS/2 here, USB 2.0 here with extra power. 8 USB 3.0 on the back, and I'll cover that first, how these get their bandwidth. We have HDMI has a plug in it here. DisplayPort here, SPDIF optical. And we have a 1 gigabit NIC that I talked about, the Killer E2205, gold-plated audio 7.1, and this is the amplified port, the output for your headphone. MSI is good at making everything red here, and everything matches. Aesthetics are killer. This is for your Bluetooth and AC wireless antennas. Okay, so I'm not going to hold the board like this because that's just awkward, right? So, flipping it, because that's not awkward. Okay, ladies and gents, this is what you come here for, right? My circuitry analysis. I think that's what people come here for. It's not my witty banter. Well, I wish it was. I'd do stand-up if someone would pay me. But, heck, maybe the ads on YouTube will pay. Okay, so AS media controllers. Okay, so how do you get 8 USB 3.0 from the back panel? Well, first step is you need USB 3.0. And MSI has not routed any native USB 3.0 to the back panel. Instead, they have used 3 AS media chips. Boom, the controller, Boom Hub 1, and Boom Hub 2. So, starting off, this is the ASM 1042AE. This is a very common USB 3.0 controller. Don't confuse 1042 with 1142. 1142 is USB 3.1. And this board is doesn't have 3.1. Most Z97 don't. But this is USB 3.0 1042. Okay? 2 ports output from 1 PCIe lane. Or 2. Actually, I think maybe MSI is using 2 here, because that would make more sense. 2 PCIe lanes, 2 USB 3.0 out. Those 2 USB 3.0 out, one goes here, and the other one goes here. These are 1 to 4 hubs. So they turn 1 USB 3.0 into 4 USB 3.0. So that's how you get 8 on the back panel. This is an NXP level shifter. I'm not going to go through the model name because it's really not important. But what you got to know is DisplayPort or digital video is the native output that goes for any of the digital outputs. I think there's also a native D-sub output for the VGA port, but there's no VGA port on this board. Anyways, Intel CPU from the IGP outputs this digital video, which can be just routed to DisplayPort pretty easily. But for HDMI or DVI, and this chip supports either or, you need a level shifter to convert digital video to HDMI or DVI. Okay, cool beans. Anyways, moving along. Oh, here's our killer NIC, E2205. Pretty integrated thing too. And here we have our voltage regulator. And if you guys haven't seen my VRM list, it's up there. I don't think this board's on it though. I really gotta update that. Maybe someone wants to help me with that because it's a lot of work. Am I floating? I'm floating. Woo! Okay. ISL 6388, one of Interstill's latest and greatest 6-phase PWMs. Interstill is known as being an analog company, and Zyker Labs is actually one of Interstill's companies that makes digital PWMs. However, there's been a huge demand for digital PWMs recently, especially overclocking, and Interstill has to meet the demand. So Interstill has released their 6388, which is a fully digital controlled, digitally programmable PWM. It's a hybrid on the inside, so it takes the best of analog and the best of digital and puts them together. But then it's also pretty digitally controlled. It's mostly a digital PWM, but not all the way, which really makes no difference here. Light load efficiency is excellent. Full load efficiency is also excellent under a thermal camera. It's brilliant. I'm running out of adjectives, so I'm sorry. So let's flip it over. There's something else you need to see. So it's a 6-phase PWM, but you saw 12 phases, right? So this is Interstill ISL 6611A or 6611A. These are doubler/dual drivers. Now how do these work? It takes one PWM lane, one PWM channel, and splits it up. Oh, so PWM 1 goes in, and then PWM 1A comes out, and 1B comes out. So every 2 phases goes to this. Now, this doesn't output PWM channels. Instead, it outputs driver channels. So these are doublers/dual drivers. So these drive the MOSFETs on the back. On the front, okay. So the MOSFETs. What we're dealing with here are power packs. Power packs are in this package. These are from Nikos, and you know they make a lot of D packs, but these are not D packs, and these have all the good qualities of the low RDS on power packs. And these are, I believe, the low side is a PK632, which would be the ones closest to the chokes, PK632. Ones furthest away are the high side, and those are PK616, I believe. Yes, 616BA. PK616BA. Memory VRM uses the same MOSFETs. Ooh. Memory VRM uses the same MOSFETs, but a UP1504, or yeah, 1504 PWM right here, single phase, analog, and they doubled up the number of MOSFETs to provide better thermals and better stability for high overclocks. There's some other stuff I gotta go over. OC Genie is MSI's proprietary auto OC button. You press it in, it lights up, it's overclocked. You depress, it's not overclocked anymore. Of course, you need to restart. So yeah. Power reset buttons, kind of crucial. And voltage read points, very crucial. If you want to read the voltages nowadays inside the CPU, well, you can't really get in there, and you can't really go to the VRMs because they're just outputting basic voltage for the CPU to convert into its other voltages. So nowadays, you basically need voltage read points to know the voltage, the real voltage, not software. Moving along, oh, here we got some goodies. This is USB 3.0 internal headers. Notice the right angle header. This right angle header is from Lotes, and it's quite a pricey part. So let's let it float, 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 float. So this is the Lotes. Lotes is, I think, one of the only, if not the only, company that makes this header right-angled. There's also a not right-angled, so you can pick or choose or use both. But that's not what's special. What's special are these 4 chips. These are ASM 14, I believe 14, let me search my memory, 1464 I believe, but I'm not really sure. Hold on, let me check 1 second. Yeah, okay. ASM 1464, yeah. ASM 1464 are USB 3.0 redrivers. So what's a redriver, right? So, I don't really know if they're really needed here, but I think MSI wants to push it far. So, digital and audio signals, digital is better than analog at going long distances, right? Digital is just a 1 and a 0, so pulse, no pulse, pulse, no pulse, or pulse, low pulse. Analog, it degrades over long distances. There are equations that can accurately tell you with resistance and the length, how much the voltage will drop for the analog signal. Redrivers overcome these perils. So basically this means that these redrivers here, they're not redriving the board signal. Basically they're redriving the board signal not to increase the board performance, but to increase the cable length performance. So if you have a long cable in these, for a long USB 3.0 internal header that goes, it's maybe more than a couple feet, these, the redrivers help ensure optimum performance and stability at longer distances. That's what they're there for, and this is not something I see on all boards. This is something MSI gets huge props for, because I love stuff like that. It's called engineering, and I like it. Anyways, so here we have Sata ports, right? Sata 6 GB per second, all of them. But Intel PCH only outputs 6. So how do we get 8? Well, they're using a 1061 from AS Media again, an ASM 1061. This takes 1 PCIe from the PCH, routes here, and outcome to SATA 6 GB per second. These 3, however, or these 6, because each one of these is 2, are from Intel, and this is from AS Media. Postcode, port ADH, very nice, and actually quite hard to get nowadays without it built into the board. You can get through the TPM module, and you can get through PCI, but there's no PCI on this board, and there is a TPM module, I'm pretty sure. Oh, actually there's not. But in the future, they mandate by law. Actually, these might be TPM. So yeah, I think this is TPM. You can get through TPM, but they don't sell those things in the US. Dual BIOS switch. You can switch between the BIOS A or BIOS B. Okay, they're not linked. This switch helps you switch it, so it's not automatically going to recover itself. This is a Nuvoton NCT 6714, I believe. Oh no, 6792D, right? This is the Super I/O, controls all the fan, voltage, temperature monitoring, and all the goodies, yeah. M.2 port. This is 2X PCIe 2.0 from the PCH directly, and this is for M.2. Okay, I believe that's 10 gigabits per second. Each PCIe 2.0 lane is 5 gigabits, okay? Alright, let's cover the audio, because this is the sick part. Okay, so, you see there's two controllers here. This is a C-Media 6631. This is a Realtek ALC 1150. These do not work together. Excuse me. They work separately. So, there's this divide here in the PCB, and it's right above this PMC. This is a flash ROM for this, 1 megabit. This is a power switch, and this is a power plug. There's a adapter provided in the box with the accessories, and this will allow you to use extra power into this, because this has a bunch of amplifiers and a lot of components. Anyways, we'll cover not the Realtek first. We'll cover the C-Media first. C-Media controller right there, right? This is 120 dB SNR, 192 kilohertz, and I think 24, 32 megabit bit rate. Anyways, the 120 dB, very high quality. Supports ASIO if you like recording and stuff like that. Cool stuff. This, I believe, I'm not really sure, but it's labeled 451331. I believe this is an extra power module that controls and allocates extra power to stuff. This is a Wolfson digital analog controller. All these signals come out of here are digital, ones and zeros. They need to be converted into waves so we can hear them through headphones. That's what this does. And this is a Wolfson, I believe it's a WM8741, 128 decibel SNR. Very high, very good. Then we have two amplifiers. We have two LM4562s right here. And we have this big amplifier, big boy right here, from Texas Instruments, and that's a TPA 6120. These are all very good quality, and they help amplify the output. This is a Cirrus Logic analog digital converter. You saw the digital analog converter, the DAC, the Wolfson earlier, right before this. This is the exact opposite. This takes the input and converts into ones and zeros for the C-Media chip. That's a Cirrus Logic CS5346, 103 decibel SNR. There are 21 Nichicon Gold capacitors for audio, just for this, and all this powers the front audio header. So this is high quality audio, not for the back panel, but for the front panel. I'm pretty sure of that. And this, what are you wondering, what is this relay for? Like, what the heck is this? And I went on Newegg and I saw that a lot of users were like, what the heck is this thing? Why am I getting ticks? Why my motherboard sound like kind of like a bomb when it turns on? And it does click a lot because it's a relay. It's a mechanical relay. It's physical. This basically ensures there's no depop. So, or it does do depop. So, you know, sometimes you turn on the computer and you get this popping sound out of your speakers and it kind of startles you. This ensures that doesn't happen with a little tiny ticking sound when you start up. It's not a big deal. It's actually quite good. And it's like, hey, that's my hardware. Your board can't do that. Mine can, right? And it's something to be proud of. Don't be sad about circuits. Circuits are stuff to be cool. I mean, happy about. Okay. ALC 1150 right here. Now, a lot of manufacturers using this now basically because everyone has an amplifier. If you don't have an amplifier and you don't have a differential and you only have an ALC 1150, it doesn't provide 115 dB SNR. It provides much less. I think 105 actually, or even 98 or something like, actually maybe 105. But if you have an amplifier like everyone does these days, you get 115 dB SNR in the output for the headphones. And this is a OPA, or is it OPA? Yeah, it's OPA 1652. Okay. High quality. Then we have WAMA film capacitors, very nice, and a bunch of Nichicon Gold capacitors. I think this might be like 11 or something. 2, 4, 6, 8, 10, 12, 13. Cool, lucky number for some people. Yeah, so that's that. And then lastly, let's cover some of these PCIe for me. Okay, so this clock generator here is for the PCIe from ICS. There's no need to know what number it is. It doesn't make any difference. But this is the ICS clock gen, and it provides 100 megahertz for the output for the PCIe cards. Okay. zooming out here, we have a bunch of PCIe lanes. So people are kind of wondering, what is the PCI allotment here? So just like other Z97 motherboards is limited. It's limited because the CPU. PCIe controller only supports 16x PCI 3.0. You can't go higher than that, okay, but you definitely can go lower. Anyways, let me explain it like this. These small ones are all PCI 2.0. They're all directly routed to the PCH. So let's move them out of the equation. They don't matter anymore. Okay, I'm sorry, guys. Anyways, there are 6 PCI 3.0 quick switches from AS Media. I think they're ASM 1480s. Okay, and they each switch 2 PCIe lanes in 1 or 2 directions. So this can switch 2 lanes either here or here, stuff like that. But actually, that's not how it works. So 16x comes out of here in bundles of, I believe, 4. So, or 2. And the first 8x here is hardwired to the CPU. Boom. 8x. Boom. The second 8x is where we get our magic. Now, you have to understand, first of all, that I'm going to have to go through 3 levels just to show you 2 levels. So basically, you understand the concept of 16x here, but then if you need 2 cards, 8x switches from here down here. So 8x is removed here and moves here. And now let's say you put a card here, and then since 8x is here, this 8x shrinks to 4x, and this 4x here goes here. Okay? You have to understand that's how it works. 16, 8, 4. That's how they're hardwired. Well, this is actually wired for 8, but it can't do 8. It can only do 4. 16, 8, 4. 2 cards, 8, 8. 3 cards, 8, 4, 4. Cool? Cool. Now, these PCI switches work like this. All 8x are routed here. The first 8x is routed hardwired here. The second 8x is all routed to these switches here. So this 4x, if you take these two, it's 4x, are routed hardwired here. Well, not hardwired here, but can switch between here or the third 4x here, because the first 2 4x are hardwired. This 2 4x route down here, or they go up here. So basically, this can allow it to go here, here, or 8x, 4x here, here. So basically, these switches help enhance this switch, so that makes it 3-way with these 2. So yeah, basically that's how it works. If you want to see a diagram, I don't think I explained it that well, but you can see a diagram on the side. Or really, this is the standard Intel PCIe allotment. Nothing special about it, but that's how it works. 16, 8, 4 hardwire. Then you go 16x 0, 0, 8x 8x 0, or 8 4 4. Okay. So this 4x switches this 4 over here, or here, or here. Well, because of how it's done. Well, yeah, just between here and here, and this switches this 4x between here and here. Okay, a little confusing, doesn't matter. I just confused the heck out of you before I ended the video. Anyways, more good videos like this to come. Please stay tuned for more. I hope you enjoyed the video. If you got any comments or suggestions, please let me know.